Here's an integral. Find the integral of dx over x squared plus 5x plus 7. Now, this is not like the usual integral that you know, because this cannot easily be factorized. So what we can do here is that we can just complete the square and we'll be able to go. So that's the first step when you have such integrals. All right. So these integrals, they are called the integrals of type 1. And usually when you have such an integral, all what we are trying to do is to transform it into a form which will be able to integrate properly. All right, so we are going to first complete the square here. So if we complete the square, what do we get? So completing the square here, okay, we end up having x on top over, down here we're going to have x. The half of 5 is just 5 over 2. Of course, we'll be squaring that one, plus, of course, the same 5 over 2, when we square it, you subtract it to 7, which will give us 3 over 4. So this is the situation which we have, because 7 minus 25 over 4 will give us 3 over 4 when you do the fraction part. Okay, if that's the case, then let us move. So once we reach this stage, we are going to say let u be equal to x plus 5 over 2, and let v squared be equal to 3 over 4. Our main aim is to have this form. Okay, once we have this form, all right, we can now, let me not even just say this form, is to have this form where we have this plus v squared. It will be easier for us to differentiate, to integrate this one, because this is just an integral of tan inverse. Okay, so this is what we need to transform this function of ours that we have there. So given that u is equal to that, because there's already a square there, so u to fit, then with the 3 over 4 we can put it as a square. So this will give us dx over u squared plus v squared. Now, ladies and gentlemen, based on what we've been given, okay, based on what has been given, here's what you need to know. All right, so here what we are having is just the integral of dx over u squared plus 3 over 4, because this squared is just 3 over 4, right? Now, this is just an integral which results into the inverse of tan, like I said in the first place, which just give us 1 over u. I'm just trying to, sorry, 1 over v. Okay, this is a v, all right? So 1 over v. Then we have tan inverse of, okay, so we have u over a. Now, in this case, we can't put a, but it will be what? This is our u, good. So u over v, of course, that's plus c. This is what we're trying to get. So in this is the case, what are we trying to say here? We're trying to say this will now result into u squared plus 3 is equal to 1 over root of this. This is v. Remember that 3 over 4 is v squared, right? So v is the square root of everything here, which will give us root of 3 over 2. Then we have tan inverse u. What is u in this case? Just keep it the way it is. U over v, we said it is root of 3 over 2. We can continue and say this will give us, when you reciprocate here, will give us 2 over root of 3. Then we have tan inverse. Here we're going to have 2u over root of 3. Go back and check what was u. U was x plus 5 over 2. U was equal to x plus 5 over 2. So now we can now substitute. Okay, we can now substitute and say this will give us 2 over root of 3 tan inverse of 2, open brackets, x plus 5 over 2. Are we there? Everything here over root of what? 3. Okay, plus what? C, of which we can now say the integral of dx over x squared plus 5x plus 7 is just equal to 2 over the root of 3, and we have tan inverse of what? 2x plus what? 5 over root of what? 3 plus c. Thank you so much for following us in this video, and we hope that we enjoy more of these. Now, in case you're wondering where this is coming from, this is just the integration of rational functions. This is the integration of rational what? Of rational functions. All right, we know that rational functions are functions that can be expressed in the form of a over b or r over t, anything, as long as the denominator is not equal to what? Equal to 0. So in that case, thank you so much, and see you.